Alright, today is January the 26th, 2018. This is going to be page 12 in our binder. Alright, so today we are going to be simplifying radicals. So a radical, pretty much the basic term of it is a square root. It won't get more complicated until you go to Algebra 2, so that's all we need to know. So in order for us to start, we need to understand what a perfect square number is. 144 is 2 times 2, or the square root of 144 is 12. 12 times 12. So the square root of 144 is 12. That's why 144 is a perfect square number. 64, the square root of 64 is 8. Why? Because 8 times 8 is 64. Square root of 36, 6. 6 times 6 is 36. Square root of 25 is 5. Square root of 16 is 4. The square root of 4 is 2. Alright, so now we don't have not all our numbers are going to be perfect square. But what we're going to do is we're going to get the number that's in the radical, or the one that's being square rooted, and we're going to break it down into two factors that still multiply to give me 50. 25 times 2 give me 50, but one of them will be a perfect square number. Some of us maybe you thought like, okay, well, why don't we pick 10 and 5? Well, 10 times 5 do give me 50, but neither one of them are a perfect squared number, so I can't square root it. So that's why we don't use this one, we use this one. The square root of 25 is 5. So I can break them apart into two square roots. This one doesn't have a square root, so it stays in the square root. And this one, the square root of 25 is 5. So the simplified version of the square root of 50 is 5 square roots of 2. Okay, we have a few more examples. Let's go and do the ones that we have to fill in the blank. So 128 can be broken down into 64 times 2. 64 is a perfect square number, so we separate them into two square roots, or two radicals, and the square root of 64 is 8. 192. 3 times 64 is also 192. You break down the 64 from the 3 into its own square root, or radical. Square root of 64 is 8. 288. 2 times 144 will give me 288. We can separate that into its own square root, and that will give me 12. So my simplified radical of square root of 288 is 12 square roots of 2. 72. 2 times 36 will give me 72. 36 is a perfect square number, so we can square root it to give us 6. 48. The square root of 48, we cannot do it, so we have to factor it out. And it's going to be 3 times 16 gives us 48. And then the square root of 16 is 4, so no more square root, and bring down the square root of 3 because that couldn't be square rooted, and that is our answer. 108. So when you don't know what to break them into, I suggest you always start with dividing it by 2, just in case you're not sure. So we're going to go 108 divided by 2. Okay. Well, 54 is not a perfect square number, so that's not going to be our answer. So then let's go 108 and 3. 36. 36 is a perfect square number, so it is 108 can be broken down to the square root of 36 times 3. Well, square root of 36 is 6, so my answer is 6 square roots of 3. Okay, so this is the basic that we need to know in order for us to do the next part. Backside. On the backside, 1, 2, and 4 are adding or subtracting radicals. Okay? So we're going to look at the radical. If they are like radicals, then they can combine. So remember when we do combining like terms, this is going to be combine like radicals, meaning they have to have the same number under the square root in order to combine the number in front of it. So here a really quick example would be 2x plus 1 plus 4x. These are like terms, so those can combine, and this will simplify to 6x plus 1. The 2 and the 4 combine to give me 6, and the 1 cannot combine because it's not a like term, and this would be my simplified answer. This is very similar if I had something like 2 square roots of 2 plus 1 plus 4 square roots of 2. These two have the same square root and the number underneath it, so radical, they have the same radical. So I can combine 2 square roots of 2 plus 4 square roots of 2. Now I have 6 square roots of 2. So these combine and then bring down the 1. It cannot combine with the square roots of 2 because it doesn't have 1. So it just stays like that. That is my simplified radical. So let's simplify number 1. We have 8 square roots of 3, and there's another square root of 3 over here. They have the same radical. If there's nothing in front of the square root of 3, there's a 1. So then I can combine these. It's a positive 1, so it's 8 plus 1 is 9 square roots of 3. Okay. Then I have 4 square roots of 2 minus 1 square root of 2. So 4 minus 1 is 3, positive 3 square roots of 2. So we've combined our radical as far as we can go, and this is our answer. On number 2, none of the radicals are the same, so none of them are like radicals. So I cannot combine them the way they are. So I'm going to simplify the radicals like we did in the front part of our notes. So 3 cannot be broken down into anything other than 1 and 3, so it's going to stay the way it is. So let's move on to the next one. 12 can be broken down into 2 times 6 or 4 times 3. Now 2 and 6 are not perfect square numbers, neither one of them. So we're going to go with 4 times 3. 4 times 3 gives me 12, and 4 will be a perfect square number, and I can square root it. The square root of 4 is 2, and then the square root of 3 does not have a perfect square, so we just bring it down inside the radical. Be careful though, this 4 is outside touching the square root, meaning whatever comes out has to be multiplied by that 4. So bring that 4 down and multiply it times the 2. So 4 times 2 is 8. Okay, and it's a positive, so put plus. In front, I can bring down the 5 square roots of 3, and you can tell they're already like radicals. Let's simplify the 75. Well, kind of gives you a hint. These are already square root of 3, square root of 3, so you can give it a try, and 75 divided by 3, in case you weren't sure, 75 divided by 3 is 25. So I can break this down into 25 times 3. I like to put the perfect square number in the front so that when I square root it, it's already close to the front where I'm going to leave it in front of the radical. Square root of 25 is 5. Square root of 3 stays square root of 3. And then don't forget there's a negative 2 in the front, then I need to multiply by that 5. That's going to give me negative 10 square roots of 3. All of these are like terms now, like radicals. So I can look at the first number and combine them. 5 plus 8 is 13. 13 minus 10, negative 3 square roots of 3. Okay, just in case though, you always want to check it. So let's check it with our calculator. Ugh, that glare. That help? Okay, so let's type it in. 5 square roots of 3. Make sure you don't stay under the cursor. Click to the right, then put plus 4 square roots of 12. Click to the right, minus 2 square roots of 75. Enter. Okay, it gives me that decimal. Let's plug in our answer. Negative 3. Oh, excuse me, it wasn't a negative 3. That was 5 plus 8 is 13. 13 minus 10 is 3. My bad. 3 square roots of 3. Okay, see how we got the answer? So far we didn't change anything. It's still correct. So we're good. That's how you can check your answer if you simplify. Jump to 4, we'll come to number 3. Number 4, you cannot find these because they're like radicals. So we have to simplify or factor out the 20 to get radicals. 20 can be broken down to 2 times 10, 4 times 5. The 4 times 5, 4 is a perfect square. That's why it's the better. So it's going to be 4 times 5 because 4 is a perfect square number. So let's square root the 4. That's a 2 and bring down the square root of 5. Don't forget there's a 10 in the front, so bring it down and multiply it. 20 square roots of 5. Now let's do the 9. 9 square roots of 45. Break down the 45 into 45 divided by 5 will give me 9, right? So it's going to be 9 times 5 is 45, and 9 is a perfect squared number, 3. Square root of 9 is 3. Bring down the square root of 5. Don't forget there's a negative 9 in the front. Bring it down and multiply it times the 3. Negative 27 square roots of 5. Now these are like radicals, so now they can combine. 20 minus 7, negative 27 square roots of 5. Number 3. There's a rule we need to know about multiplying. When we multiply, we can only multiply the numbers that are outside the radical by the numbers that are outside the radical. So outside with outside and inside with inside. So here, the 3 and the 5 are outside, those I can multiply. So the 3 and the 5 are outside. I can multiply those. 15. The 6 and the 2 are radicals. They're both under the square root. So those I can multiply to give me 12. Outside with outside, inside with inside. Now, I cannot leave it like this because this is not the simplest form. I know that 12 can be broken down into 4 times 3. Square root of 4 is 2. So this 12 just changed to 2 square roots of 3. Bring down the 15. Remember it's in the front touching, so it's multiplying. So my answer is 30 square roots of 3. So let's try it again. So the rule is outside with outside, inside with inside. And here, since we have a parentheses and a 3 in the front, square root of 3, we're going to distribute inside. That's square root of 3. So square root of 3 times square root of 2 is square root of 6. Square root of 3 times square root of 5, positive square root of 15. 6 can be broken down into 2 and 3, but neither one of them are perfect square numbers. So it stays the way it is, or leave it how it is. Then 15 can be 3 times 5, but neither one of them are perfect square numbers either, so it stays how it is. This is our answer. Alright, number 6, we're going to distribute again. But this one definitely, you need to remember that the outside has to multiply with what is outside, and the inside with what is inside. 3 square roots of 2, 3 times 3 is 9, square roots of 2 times 3 square root of 8, would be square root of 16. Then we do the next one. 3 times negative 4 is negative 12. Square root of 2 times square root of 3, square root of 6. Just like we said over here, the square root of 6 cannot be broken down into anything else, so this stays how it is. But we all know that the square root of 16 is 4. So this is going to be 9 times 4. 9 times 4 is 36. So leave it as 36 minus 12 square roots of 6. Last one, find the area of the rectangle. We know that area is length times width. So we're going to do 2 plus square roots of 2 times 4 minus square roots of 2, but it has to be in parentheses, kind of like when we have binomials. Now we're going to do the rainbow method or FOIL. So we're going to do 2 times 4. Well, 2 times 4 is just 8. Now, remember the rule. When we multiply outside with outside, inside with inside. So here, when I multiply the 2 times the negative square root of 2, there's nothing in the front, so put a 1. So I can only multiply that 2 times that negative 1, which will be negative 2, but the square root of 2 has to come along. Kind of like when we have an x, negative x. So if I had 2 times negative x, it would be negative 2x. So when I have 2 times negative 1 square root of 2 is negative 2 square roots of 2. Next one, we have a 1 in front, so 1 square roots of 2 times 4 is 4 square roots of 2. The 4 can multiply with the 1 outside and bring the 2 along, square root of 2. Now this one, square root of 2 times negative square root of 2, it's kind of like a 1 times a negative 1 will be a negative 1. And then these are both inside, so those can multiply to give me a 4, square root of 4. These middle terms will combine, they're like radical. So I have a negative 2 plus 4 is a positive 2 square roots of 2. Bring the 8 down. And then this, we have a negative 1, but the square root of 4 is a 2, so times 2. Negative 1 times 2 is negative 2. But we still have that 8 in the front, and that's a regular 8, and that's a regular 2, so those can combine. So 8 minus 2 is 6. My answer is 6 square roots of 2. 6 plus 2 square roots of 2. Alright guys, so the last thing that I needed to go over with you guys was an example in our assignment that we didn't go over in our notes. We have square root of 7 squared. We know that when we raise something to that exponent, it means that we're going to multiply it by itself that many times. Since it's a 2, then we multiply that 7 times itself, square root of 7 times itself twice. Well, since they're both inside the radical, I can multiply them. Gives me square root of 49. But I know that the square root of 49 is 7. So our answer is 7. Well, check this out. When I square something and when I square root it, those are opposites of each other. So when I have both of them together, they cancel each other out, and I'm left only with the 7. 7. Watch out on number 10 though. It's not exactly the same because they're not both under the square root. There's a 3 outside. So for sure you want to write this times itself twice. And remember the rule. Outside with outside, inside with inside when we multiply. Alright? Okay, front and back, your homework is 1 through 20.